Air heaters. In this lecture, we are going to talk about recuperative air heater and regenerative air heater. The regenerative air heaters are of two types, Ljungstrom air heater and Rothemuhle air heater. We are going to discuss both of them. This is the boiler components diagram. In this diagram, we can see that in the flue gas path, air heater is coming directly after the economizer. The temperature of flue gases downstream of the economizer is still quite high. It is between 588 to 698 degree Kelvin. The remaining heat in these flue gases is trapped in another heat absorbing surface called the air heater. The air heater uses a colder heat receiving fluid, that is ambient air, and thus the outlet flue gas temperature from the air heater is reduced to about 393 to 433 K, while the temperature of the ambient air is raised from atmospheric to about 523 to 613 K prior to using this hot air in combustion. The heat recovered is recycled to the furnace by the combustion air and is added to the energy released from the fuel. This higher heat energy is further absorbed in evaporating and or the superheating surfaces, resulting in gain in boiler efficiency and less fuel consumption for the same output. The fuel savings are almost directly proportional to the rise in air heater outlet air temperature. For a 110 K air temperature rise, typical fuel savings are about 4%, and for a 280 K air temperature rise, fuel savings are about 11%. Beyond fuel savings, air preheating is also required for drying coal in the pulverizer. The typical air temperature for drying coal ranges from 423 to 588 K. When considering the principle of operation, there are two types of air heaters, recuperative or regenerative. The heat transfer efficiency of regenerative air heaters is high compared to the efficiency of recuperative air heaters. However, the disadvantages of regenerative air heaters are leakage of air into the gas space and transport of fly ash into the combustion air system. Request. It is hoped that this session is going to be useful to you. Please press like button. Please सब्सक्राइब दिस चैनल. यह लेक्चर हिंदी में भी उपलब्ध है. Recuperative air heater. This is the diagram for recuperative air heater. In a recuperative air heater, heat from the flue gases is transferred continuously to air through a heating surface. In this type of air heater, the metal parts are stationary and heat is transferred by conduction through the metal wall. A commonly used recuperative air heater is the tubular type, but for lower air and flue gas pressures, the air heater can also be the plate type. Tubular air heaters are normally the counter flow shell and tube type, where hot flue gases pass through the inside of the tubes and air flows outside the tubes. Baffles are provided to ensure maximum air contact with hot tubes. These heaters, however, consume much metal and occupy a large space. Regenerative air heater. In a regenerative air heater, the heating surface is swept alternately by the flue gas and the air undergoes alternate heating and cooling cycles and transferring of heat by thermal storage capacity of the heat transfer surfaces. The gas and air counter current flows move through the heat transfer element separately and continuously. Thus, when half of the heating elements are exposed to flue gases at any instant, the other half is exposed to air. This air heater may include either rotating heat transfer surfaces with stationary air/gas distribution hoods, for example, Ljungstrom design as shown in figure, or rotating air/gas distribution hoods where the heat transfer surfaces are stationary, for example, Rothemuhle design as shown in figure. Ljungstrom air heater. The diagram of Ljungstrom heater is shown. The rotor of Ljungstrom air heater is driven by a motor and has several radial members that form sectors. Two opposite sectors are provided with stationary seal covers. The heat transfer surfaces are comprised of corrugated, notched or undulated ribbing steel sheets that form baskets. They constitute the heat storage medium of the air heater. As the rotating sectors enter the hot gas zone, they are heated by the gas and they store the heat as sensible heat. When they enter the air zone, they progressively release the heat to the air. Rothemuhle air heater. This is the diagram for Rothemuhle air heater. The principle of heat transfer from hot gas to cold air is identical to that of the Ljungstrom air heater. The Rothemuhle type regenerative air heater uses stationary heating surface elements and rotating ducts. The heating surface elements are supported and contained within a stationary cylindrical shell called the stator. Two opposite sectors are provided with stationary seal covers. Heat is transferred as flow streams are directed through the heating surface in counter-flow fashion. One flow stream inside the hoods and the other outside. Either air or gas may pass through the hoods. However, air is more common because it requires less fan power. Ljungstrom air heaters, however, are better for commercial use due to better heat transfer and lower leakage, sometimes less than 5%. Request: it is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। यह लेक्चर हिंदी में भी उपलब्ध है। This lecture is dedicated to the loving memory of my late parents, Shri Om Prakash Chadha and Srimati Sudarshan Chadha. Maiden name Mohan Dai Suri.